Good morning everyone. Welcome back to next lecture. Today we are going to discuss matrix operations. See, the matrix operation refers to a mathematical operation performed on the given matrix. And these operations mainly include addition, subtraction, multiplication and various other transformation. Today we will discuss here the operations like matrix addition and subtraction, and then we also discuss the scalar multiplication. See here, addition of matrices. The matrix addition is a fundamental operation in general linear algebra. If we have two matrices, for example, say matrix A and matrix B, then the addition of two matrices, that means A plus B, which require that the matrix be a equal dimension and order. So one of the important requirement for the addition of matrices, that means it require equal dimension and order. So in this case, each element of a one matrix then added to the corresponding element of the other matrix. So thus in matrix addition, corresponding element of two matrices are added together to form a new matrix. But the condition is that matrices being added must have same dimension. That means the number of rows and columns are equal in both given matrices. If the number of rows are not equal to the number of columns, that means the number of rows and columns are different between the given two matrices, then matrix addition is not possible. See, consider here, matrix A is given, that is A11, A12, A21, A22. We have a 2 by 2 matrix, and we have the another matrix, that is B is equal to B11, B12, B21, B22. And we want to add these two matrices. So then we can say that it is the addition of matrix. So we want to find A plus B. So in order to find A plus B, let us check whether the given matrix are equal dimension or not. That is, number of rows and columns are equal in the both given matrices or not. So here, see, in the given matrix, that is A is equal to A11, A12, A21, A22, and matrix B is equal to B11, B22, B21 and B22. Then here, what we are generally doing? We are going to add A11 with B11. A12 with B12, then A21 with B21, A22 with B22. So here matrix addition, where matrices are the same order here, because we have a 2 by 2 order, and when we are adding two matrices, each corresponding element in the matrix is added together to form a new matrix. So if you go for adding A11 plus B11, see, it will become A plus B is equal to, it is A11 plus B11, A12 plus B12, A21 B21, A22 B22. So in this way you can multiply, and accordingly you simplify it, you will get A plus B, that is matrix addition. So consider one example. We have a two given matrix. See, matrix A is equal to 3, 4 and 1, 2. Matrix B is equal to 2, 5, 8, 4. We want to find out A plus B. See, we can check that here we have 2 by 2 matrix. Matrix A is equal to 2 by 2 matrix and matrix B also 2 by 2 matrix. So we can say that matrix addition is possible. So how we are going to add? See, we have these two matrix. Then we are going to add 3 plus 2. The first element of the both matrix, that is 3 plus 2, 4 plus 5. Similarly 1 plus 8, 2 plus 4. So here 3 plus 2, 4 plus 5, 1 plus 8 and 2 plus 4. You can simplify it. 3 plus 2 is equal to 5, 4 plus 5 is equal to 9, 1 plus 8 is equal to 9, 2 plus 4 is equal to 6. So A plus B is equal to 5, 9, 9, 6. So in this way you can add two matrices. See here, consider another example of 3 by 3 matrix. See, matrix A is 8, 9, 7, 3, 6, 2, 4, 5, 10. matrix B is equal to 1, 3, 6, 5, 2, 4, 7, 9, 2. See, we have the same order. The matrix A is equal to, it is a 3 by 3 matrix, and matrix B is also a 3 by 3 matrix. So we can say that matrix addition is possible. And what do we want to do? We want to add each element corresponding to the element in the given matrix B. So here 8 will be added with 1, 9 will be added with 3, 7 will be added with 6. Similar way, in the second row, with the second row in the matrix A, in the second row with matrix B. So it is 3 plus 5, 6 plus 2, 2 plus 6, accordingly the third row as well. So you can write it, A plus B is equal to 8 plus 1, 9 plus 3, 7 plus 6. Accordingly you can simplify it. So if you go for simplifying it, then it will become 8 plus 1 which is equal to 9, 9 plus 3 which is equal to 12, 7 plus 6 which is equal to 13, 3 plus 5 which is equal to 8, 6 plus 2 which is equal to 8, 2 plus 4 which is equal to 6, then 4 plus 7 which is equal to 11, 5 plus 9 which is equal to 14, 10 plus 2 which is equal to 12. So in this way you can go for adding the various elements in the given matrix. Now let us consider one matrix, that is matrix A is equal to 5, 4, 7, 2 and matrix B is equal to 6, 8, 1, 9, 5, 8. See, we want to find out A plus B here. See, in this matrix addition is possible? No. In this case, matrix A has dimension of, it is 2 by 2. That is, we have 2 row and 2 column. And matrix B is 2 by 3 matrix. We have 2 row and 3 column as well. So, since the number of rows and columns are different between the two matrices, then matrix addition is not possible. In this case, the matrix addition is not possible. Matrix addition is not possible when the matrix involves do not have the same dimension. In order for the matrix addition to be performed, then the matrices must have the same number of rows and the same number of columns. So in this case, we have a different dimension so that we can't find the A plus B. Now we are going to discuss various properties of matrix addition. See, the operation matrix addition has several properties that are crucial for understanding its behavior and how it interacts with other operations. See, the first one is adding one matrix with another with the same order, resulting in a matrix with the same size. That means if you are going for adding with the two matrices that have the same order, then the resulting matrix is also have the matrix of the same size. The second one, see, the matrix addition is commutative, which means that the order of matrix addition does not affect the result. For example, if we have a two matrix, that is matrix A and matrix B, then A plus B is also equal to B plus A. That means matrix addition is commutative, which also said that we can say the order of matrix addition does not affect the result. The another property, the matrix addition is also associative, which means that, see, the way in which you are going to group the addition of three matrices does not affect the result. For example, we have three matrices are there, then A plus B plus C. These three matrices are matrix A, B and C. Then A plus B plus C, which is also equal to A plus B plus C. So here, group of addition of three matrices does not affect the result. So we can say that A plus B plus C, which is also equal to A plus B plus C. That means matrix addition is associative. Then the fourth property, that is additive identity, is zero matrix, which means adding a zero matrix to any matrix, leave matrix is unchanged. That means if we have a matrix A and you are going to add a null matrix or zero matrix, A plus 0, which is equal to A. That means it will reproduce or the matrix will not change. So these are the various properties of matrix addition. Now we are going to consider subtraction of matrices. See, the subtraction of matrices is similar to the way of addition of matrices. The subtraction of two matrices, say for example, if we have matrix A and B, then A minus B, which require that the matrix must be equal in dimension and its order. Similar to the matrix addition, see here also we have a condition that matrix must equal to its dimension and in terms of order. That is, they have same number of rows and columns, which means, for example, see it have the same size. Matrix A is equal to A11, A12, A21, A22. Similarly, we have another matrix, matrix B is equal to B11, B12, B21, B22. So now we want to subtract the matrix B from A. So to subtract one matrix from another, what we do, simply we are going to subtract the corresponding element in matrix. Each element of a one matrix then subtracted to the corresponding element in the other matrix. We want to find out here A minus B. So here we will subtract the element B11 from A11. So consider here we have a two matrix, that is matrix A and B, which is already explained. So how we will do the operation? We will subtract the B11 from A11. So it is connected A11 with B11, A12 with B12, similarly A21 with B21 and A22 with B22. So here the first element of matrix B, that is B11, should be subtracted from the first element of matrix A, that is A11. Similarly, the second element of matrix B, that is B12, should be subtracted from the second element of matrix A. Similarly, other elements can also be found by subtracting the element of matrix B from matrix A. Thus, we will get, if you go for finding it, the A minus B, which is equal to A11 minus B11, A12 minus B12, A21 minus B21, A22 minus B22. So this, if you go for simplifying it, then you will get A minus B. Consider one example. See, matrix A is equal to 5, 4, 3, 2 and matrix B is equal to 2, 1, 8, 5, and we want to find out A minus B. So here we have the given matrix A and B. So we are connecting 5 with 2 here, that is first element of matrix A. We are going to connect with matrix B. Similarly, the second element of the matrix A are going to connect with the matrix B, second element of the matrix B. So here what we are doing, the first element of matrix B we are going to subtract from matrix A. So it will be A minus B is equal to 5 minus 2, 4 minus 1, 3 minus 8 and 2 minus 5. So it is equal to, see, 5 minus 2 which is equal to 3, 4 minus 1 which is equal to 3, 3 minus 8 which is equal to minus 5 and 2 minus 5 which is equal to minus 3. So in this way we can find the subtraction of two matrices. Now consider another two matrix, that is matrix A is equal to 8, 9, 7, 3, 6, 2, 4, 5, 10. Matrix B is equal to 1, 3, 6, 5, 2, 4, 7, 9, 2. We have a 3 by 3 matrix here. Both have the same order, that is 3 by 3. So we can subtract these two matrices again by using, see, the first element will be connected with the first element of matrix B. So the second element of matrix B is subtracted from the second element of matrix A, and accordingly the remaining values can also be done. So here A minus B is equal to here 8 minus 1, 9 minus 3, 7 minus 6, 3 minus 5, 6 minus 2, 2 minus 4, 4 minus 7, 5 minus 9, 10 minus 2. So you will get like this, and if you go for simplifying it, then A minus B is equal to 8 minus 1 which is equal to 7, 9 minus 3 which is equal to 6, 7 minus 6 which is equal to 1, 3 minus 5 which is equal to minus 2. Accordingly the remaining values can also, elements can also be found by subtracting the elements of matrix B from the matrix A. Now we want to find out A minus B from the given matrix A and B. See here, matrix A 3, 7, 11, 12, 9, 2. B matrix B is equal to 6, 8, 1, 9, 5, 8. We want to find out A minus B. So here A minus B is equal to, see we have the same order here. It is 2 by 3 matrix. We have 2 rows and 3 columns in the both matrix. So we can go for subtracting these two matrices. So A minus B is equal to 3 minus 6, 7 minus 8, 11 minus 1, 12 minus 9, 9 minus 5 and 2 minus 8. If you go for simplifying it, then it is equal to minus 3. 3 minus 6 which is minus 3, 7 minus 8 which is equal to minus 1, 11 minus 1 which is equal to 10, 12 minus 9 which is equal to 3, 9 minus 5 which is equal to 4, 2 minus 8 which is equal to minus 6. So in this way you can find the subtraction of matrix B from matrix A. Now consider the another two matrix, that is matrix A 5, 4, 7, 2, matrix B 6, 8, 1, 9, 5, 8. See here, is this matrix subtraction is possible? No. In this case matrix A, see here, dimension of 2 by 2 matrix. We have 2 rows and 2 columns. And matrix B has dimension 2 by 3. We have 2 rows and 3 columns. So since the number of rows are and the columns are different between two matrices, we can say that matrix subtraction is not possible. So matrix subtraction is not possible when matrix involved do not have the same order or the same dimension. In order for the matrix subtraction to be performed, especially the matrices must have the same number of rows and the same number of columns. Then only we can perform the matrix subtraction, as just like we are explained in the matrix addition as well. Now we are going to enumerate what are the various properties of matrix subtraction. See, the first property, that is subtracting one matrix from another. If you go for subtracting one matrix from another, then the resulting matrix is also the matrix of the same size. So if you are subtracting two matrix, that is matrix A and matrix B with the same order, then its result will also be the same size or same order. The second one, see, matrix subtraction is not commutative. Matrix addition was commutative, but matrix subtraction is not commutative, which means that the order of subtraction, matrix subtraction is matter. A minus B is not equal to B minus A. So then we can say that matrix subtraction is not commutative. Similarly, matrix subtraction is not associative, meaning that the way in which we are going to group the subtraction of three matrices, for example, it does affect the result. It will affect the result if you are going to change, or the way you are going to group the matrices, then it will also affect the result. So A minus B minus C, for example, if we have three given matrices, that is matrix A, B and C, then A minus B minus C is not equal to A minus B minus C. Now we have the fourth property, that is subtracting a matrix A from itself result a null matrix. See, A minus A, you have a matrix, given matrix A, and you are going to subtract from the same matrix A, then it will equal to a null matrix. So A minus A is equal to null matrix. The last property, see, the subtracting the zero matrix from any matrix A, leave the matrix is unchanged. That is, for example, we have a given matrix A and we are going to subtract a zero matrix from the given matrix A, then it will remain unchanged. So the matrix will be equal to A only. So these are the various properties of matrix subtraction. Now we are going to discuss the scalar multiplication. See, the multiplication of matrix by simple numbers, we can say that was simple constant, or it is generally known as it is scalar. For example, we have 3, 6, 5, 2. These are some of the constant terms, or the scalar involves the multiplication of every element of given matrix by the same number is called a scalar multiplication. So we have a given matrix and we are going to multiply each elements of a given matrix by a same constant, or which is generally known as it is scalar, then we can say that it is a scalar multiplication. So in the scalar multiplication, every element of the matrix is multiplied by a single scalar value, and this operation involves multiplying each element of matrix by a scalar, resulting new matrix with the same dimension as the original one. So let us consider one example. We want to find out the value of AK, where the matrix A is given and K is equal to 3. See, what is matrix A? Matrix A is equal to 6, 12, 5, 10, 13, 2. And this is a 3 by 2 matrix because we have a 3 rows and 2 columns. And the K is given, that is 3. And we are going to find AK, that means we are going to multiply the given matrix A with K, that is K is here nothing but it is a scalar, it is a constant term, that is 3. So here we are going to multiply each element of the given matrix with 3. Then it will become, see, 6 into 3, 12 into 3, 5 into 3, 10 into 3, 13 into 3, 2 into 3. So if you go for simplifying it, then it is 6 into 3 which is 18, 12 into 3 which is 32, and remaining as like. So in this way we can find the final matrix, that is equal to 18, 32, 15, 30, 39, 6. And in this way we can find the scalar multiplication. So here we are going to multiply a given matrix with K, that is a constant, that is generally known as a particular scalar. So consider another one. Find the value of AK given the matrix A where K is equal to 2. So scalar here it is equal to 2. So here matrix A is 3 by 3 matrix. Now we are going to multiply each element of the 3 by 3 matrix A by 2, that is given scalar 2. Then it is equal to, see, we are going to multiply each element by 2. So if you go for multiplying it, then it will produce 6, 12, 10, 4, 2, 16, 14, 18 and 2. So in this way you can find the scalar multiplication. Now we are going to consider one example. See, we have given two farmers, that is Ram and Singh, who is cultivate only 3 varieties of rice, which is generally known as it is XYZ. XYZ are the 3 varieties of rice. So the sales in rupee term of these varieties of rice by both farmers in the month of April and in the month of May are given by the matrix A and matrix B. See here, the sale of April is given by a matrix A in terms of 3 varieties of rice. What are the varieties? X, Y, Z. These are the 3 varieties of rice produced by Ram and Singh. So here it is 10,000, 20,000, 30,000, 50,000, 30,000 and 10,000. These are the various elements of the given matrix A. Similarly, we have given matrix B also. This is the sales of April month. And we have given the May month sales also given here. So matrix B here, 5,000, 10,000, 6,000, 20,000, 10,000 and 10,000. Produced by or cultivated by Ram and Singh. So here our question are, we want to find out the combined sales of April and May for each farmers in each varieties of rice. And also second one, we want to find out the changes in the sales from the April to May. Then we are also find out the profit share if they receive 2% as a profit on the gross sales. Then compute the profit for each farmers and for each varieties of sold in the month of May. See, consider this question. First question, that is find the combined sale of April and May each farmers in the each varieties. So here just we want to add up these two matrices, then we will get the combined sales. So here, so the first question here, it was combined sale of Ram and Singh for each farmers in each varieties of commodity. So here we want to add the two matrices, that is matrix A and matrix B, that is A plus B. So if you go for adding these two matrices, that is 10,000 plus 5,000 which is equal to 15,000, 20,000 plus 10,000 which is 30,000, then 30,000 plus 6,000 which is 36,000, and accordingly we can also find out the remaining elements of the A plus B. So this result is actually showing that It is the combined sale of the both farmers, that is Ram and Singh, for the commodity, the rice, varieties of rice, that is X, Y and Z. Similarly, we can also find out the second question answer, that is changes in the sales from April to May. See here, changes in the sale, that means how much change in the April and May. So here we can find out the difference between these two matrices. So we can find here A minus B, which will give you the changes in the sales from April to May. So if you consider the difference between these two matrices, then we are going to subtract the matrix B, elements in the matrix B from the matrix A. So 5000 is subtracted from 10,000, which is equal to 5,000. 20,000 minus 10,000, which is equal to 10,000. 30,000 minus 6,000, which is equal to 24,000. And accordingly, the remaining elements of the A minus B can be found. So this result is actually showing that it is the changes in the sale from the April to May month by the Ram and Singh. So finally, we have one more question, that is 2% of B, that is matrix B. That means showing that we want to find out the profit share in the month of May. So it is 20%, 2%. So 2% nothing but it is 2 by 100, which is equal to 0.02. So this is a scalar. We want to multiply each element of matrix B by 0.02. Then it will become, see, we are multiplying each element of the given matrix by 0.02. It is equal to 0.02 into 5,000, which is equal to 100. 0.02 into 10,000, which is equal to 200. 0.02 into 6,000, which is equal to 120. 0.02 into 20,000, which is equal to 4,000. And 0.02 into 10,000, which is equal to 200. And accordingly, the remaining one. See, this showing that in the month of May, the Ram will receive the rupee 100 and 200 and 120 as a profit in the sale of each variety, that is X, Y, Z, each varieties of rice respectively. Similarly, see, the Singh received the profit of 400, 200 and 200 in the sale of each varieties of rice, that is X, Y, Z respectively. So this is the answer for the third question. So this will be the profit of each farmers. So let me conclude here. Today we have discussed the matrix operations like matrix addition, matrix subtraction and scalar multiplication along with the suitable examples. In the next lecture, we will continue our discussion regarding the operation of matrix operations, especially matrix multiplication. So we will see in the next lecture. Thank you.